What's up, guys? Tim Halston with DragBoss Garage. Look, we're up here a little bit early. I'm going to have Mark Campbell on about 7 p.m., which is probably about 4 minutes, and where he's going to talk about the history of the Holley Dominator and his help in development of that. It's going to be a great discussion. He's a very educated person, easy guy to talk with, so I think you guys are going to really enjoy this. I know there's some other live chats going on. John Wilburn and Andy Wood with the No Name National stuff. That's great. I appreciate you guys including me in all your chats. I like to stop by, see what's going on there. And I don't know if I'm going to be there. I know you've invited me, and I appreciate that. So we'll just see how it goes. I wanted to give a couple shout outs before Mark got on here. I haven't done a live chat in at least probably about a month or more, it seems. And I see a couple of people here, excuse me. John Wilburn, he won't be there. He said he had a meeting. He'll check it out later. Bill Fioretti. I understand, Bill. I want to talk about you in a second. Dean Stevenson. Yep. You still qualify. Lat, it's good to see you from New York. He's in a Boss 429s. You're going to like this about the 4575 Dominator that Mark developed. But let me go back to Bill Fioretti. Sorry if I was rough on your name there, Bill. But he owns mostly Mustangs. There's a picture of him there. And he's a subscriber. And he really went out of his way, and I appreciate that, Bill. He's been a long-time collector and restorer of Boss 429 Mustangs, Boss 302, Boss 351. He just sold a Boss 351 and his Boss 429 that he owned for 40 years. So he sent me this nice little folder here, and I'm going to take pictures of it, and I'll make a video on this because it's pretty, it's sentimental, and it shows that he cares, and I appreciate that. And he gave me a $100 check right here, and it's for the Cleveland project. So it will be well spent on the buildup of the Pro Stock Motors or the DragBoss Mustang. He's restored Mustangs, and he's offered his help if I need anything. So I appreciate everything you've done, Bill. And his mentor was his dad in 1978. He had a Pro Stock Pinto called Billy the Kid. Stay tuned on a feature on that. But thanks. He said he couldn't be here tonight, but that's okay. I understand. What's up, Gurney for president? Good to see you here. Joey Ritchie, good to see you here. So a couple other shout outs. I'll kind of give you a quick rundown, and then we're going to bring in Mark Campbell. So I got to give a big shout out to Bill Lyons. Blue Oval Bill. He has a machine shop, and he's the one that hooked me up with Mark Campbell. They knew each other, and he said, I think you're going to find this guy of interest. So I said, you know what? Let's hit it. So Mark and I have talked before. He's got some great stories to tell, and that's what we're going to do. Big shout out to Sherman Sly. I'm going to do a feature on with him again. I sent my carburetor to him, and he sent me it back, and he did some modifications that I've never seen before. So it just blew me away when I saw it. I can't show you, but we'll talk about it. David Cook from DC Carbs is building me a carb right now for the Cougar. We'll try that against the Pro Systems carb and see how that comes on. Matt Beineman, we're going to be talking with him from MBE Cylinder Heads. Alan Root, I got him on schedule. I got to do a Pro Stock Cam video I think you guys will find interesting. I have Pro Stock Cams from Carl Holbrook. Captain Cobra Jet, they used to call him. He was a big Ford guy. His son is Chris Holbrook Racing Engines in Michigan. So maybe you'll see this, Chris. We'll hook up. I got a chance to buy his 342 furnace brazed Cleveland with Pro Stock heads. Talked to Animal Jim lately, so he's going to be back on. Tony Bischoff with the Track Boss. We're going with 55 millimeter cam bearings. Tony said you don't see a big horsepower over regular Babbitt bearings, but it's worth it, so go ahead and do that. When you turn it over, he said you won't even believe it. So I said go for it for the 55 millimeter bearings. So let's do this. Mark's here now. he's messing with his camera. It looks like you can't see him. I'll give a couple more shout outs to people that are here. We'll bring them on board. Michael Thompson, good to see you. I'm glad you're here. It's going to be a good show. Alex Cove, you're welcome. The Parts 314, you're welcome for organizing it. Yeah, Dean, he's going to be epic, let me tell you. So here we go. I just got so many things going on, so let's rock and roll. Wow. Thank you, Gurney for president. Without further ado, we have Mark Campbell, the mischievous, notorious, electrifying.
I'm not known well at all. Most people don't know who the hell I am. That's fine with me.
I've never heard of you, Mark. Take no offense.
No, that's fine. That's fine.
So I'll kind of start this conversation and then let you take over, because since we've talked a little bit before, I can kind of mold it to where we're going to go, and then you pick up from there and carry it to the finish line. That's how I look at it. So I got to give a big shout out to my family first before we get going, Mark. Love you, Andrea. Thank you for understanding. And Izzy and Elena, thank you guys for being there. And I got Zeus, our new Doberman. He's walking around the shop here getting used to things. So thanks, guys. Appreciate it. And I thank you guys for being here, taking time from your family too. You too, Mark. Thank you for this. But here's how it goes.
Oh, my pleasure.
When I got into doing this channel and wanting to build these Pro Stock Clevelands, you got to have an induction system. And back in the Pro Stock days, the popular intakes, the UR19 and the YN tunnel ram, I mean, they cut them, they hacked them. You've seen my examples of these. And that's how they got the airflow straight, because it doesn't like to turn corners. So they were all topped by Holley Dominators. That was the carburetor of choice back then in the Pro Stock days. And it probably still was until they went with EFI, which we can forget all that. My prime period that I like to talk about usually is from 67 to about 81, 82. Those are my prime Pro Stock years in development. So Mark, I found out from a guy named Bob Lyons, and he hooked me up with Mark. He has a machine shop, and I already gave a kind of a shout out to him, Blue Oval Bob, he goes by, and he has a Cougar that he's building. So he said, you got to meet this guy. This is the guy that worked on development of the Dominator and the 4575. And I said, okay. So then we hooked up. We talked a little bit before, and here's where we're at now. So the part that I'd like you to take off from, Mark, is the Dominators that I have for these Pro Stock Clevelands I'm building are model 6464 or list 6464. So how can you give me some history in regards to that versus the 4575? Where in the evolution did it all come about? How was this Dominator? Was it Ford that thought of it and said, hey, we're going to use this on the Boss 429? Or was Holley the one that said, hey, we have this carburetor, it's 1150 CFM that we use on tunnel ports. We think we might use this for something on the Boss 429. How did it come about?
Well, first of all, I wasn't involved in the development of the 4575. When I went to work at Holley on January 3rd, 1972, I was very fortunate. They took me into the aftermarket high performance group because I didn't know anything about carburetors. I did have a degree in physics, and so they could teach me their way of doing things. I was immediately put in with all the guys that worked on the Ford Le Mans program, the Ford NASCAR stuff, the Chrysler NASCAR stuff. It was a great time. What went on, Holley was a huge company at that time. When I left Holley in 76, Holley was about a $680 million a year company. That'd be probably $6 billion a year now. I mean, it was huge compared to everybody else in the aftermarket. And of that 680 million, probably 320 million was the aftermarket department of Holley. That was broken up into racing and replacement. But we had field engineers at all the major companies, and our field engineer at Ford was a guy by the name of Roy Haroon. His dad was Ray Haroon, who won the first Indy 500. Okay, wow. And he was the field engineer at Ford. And of course, Ford was developing the Boss 429, and they wanted something a little bit bigger. And they got discussing it. Roy was discussing it with a fellow by the name of Bud Elliott, who was a Wasn't a degreed engineer, but certainly one of the best carburetor people I ever met. And they sort of put everything together. And Bud and an engineer named Bob Miller, and then Mike Urich, I believe, was the engineering manager. He put together those first Holley carburetor books and stuff like that. They sort of went together and said they got the okay to build it at Holley. It was presented by Holley as a project they wanted to do with Ford. They actually took it to, I believe, Chrysler and GM, but they turned them down. But Ford was interested. So they came out with the 1050, the 4575, and that was for the Boss 429 shotgun motor. And it was developed primarily on a 428 Cobra Jet Mustang because they didn't have a Boss 429 to work with as far as development. So it was worked out on a 428 Cobra Jet. And it was originally done as a sand casting, and it flowed 1050 CFM. When they made 200 of them initially. After that, and all the development was written off as advertising. It wasn't written off as an engineering expense. It was written off as advertising.
Nice.
Well, it went over so well, and they saw so many possibilities with it, they went to permanent mold tooling. When they went to permanent mold tooling, the airflow went up to about 285. The permanent was more efficient than the sand casting, but they had, they called it a 1050, so they just left it at 1050, even though it flowed about 1085. When I say it flows 1085 CFM, that's with fuel, and that's at 1.5 inches of manifold vacuum. Now, you would never see 1.5 inches manifold vacuum under one of those things, but that's a sort of a standard measuring thing that was used in carburation at that time. 4 barrels were flowed at 1.5 inches mercury pressure drop across the carburetor at wide open throttle, and single barrel and 2 barrels at 3 inches. So anyway, the 4575 came out, great carburetor. Then Ford decided they wanted a 45, or Ford had that in the 429. They said, we want to do a individual runner for our 302 Mustangs. And they calculated things out, and 1050 CFM per carburetor, 2 of them was going to be too small. So they went to made an 1150 version of the 4575 by enlarging the venturi from 1 11/16 to 1 13/16. The throttle bore was kept at 2 inches. And they put in a tall booster venturi, and they ran it on the Boss 302, and it was too small. And when you go to individual runner, you have to have big carburetors. So the two 1150s would only feed about a 287-inch motor. So they didn't really work out very successfully for Ford for transit. They wanted them for Trans Am racing. And that led to Ford coming out with the Autolite 1400 CFM inline carburetor. Okay, two 1400s on the 302. People think, well, that doesn't make sense, but on a pure IR, it does. And if you were to take a 426 Hemi and make it pure IR, you'd have to have two 3600 CFM carburetors to make it pure IR. Pure IR is a waste of time anyhow. It's an exercise in engineering.
So let me ask you this question, because Andy Wood from Unity Motorsports Garage wanted me to ask you this. And we're on this topic, so let's finish it off. Which is better, IR or Plenum?
Oh, Plenum, no question. Yeah.
There you go.
I mean, if you want to be frustrated, it's easier to hit your head into a concrete block wall and just finally give up than trying to make an IR system work. It's an exercise in engineering futility. Yes, if you get it right, it's going to make some really great horsepower in about a 500 RPM range, and that's it. It isn't going to drive for crap anyplace else. So Plenum is the way to go. You got to have a Plenum. And when we talk about a plenum chamber is just an open area for the pulses that come back up, the reversion pulses. Once the column of air is going through the carburetor and then through the intake runner, and the intake valve closes, and the air going in there at 250 feet per second, and it's got all that inertia, and it hits the backside of that valve, it compresses, and then comes back up through the intake tract. Right. And that's why you've got to have a big carburetor, because all that air goes right back up through the carburetor. When you're running a pure IR system on the dyno, you can see the fog of gasoline air above the velocity tubes. You know, I mean, it's just there. So the air going through picks up the gasoline in that fog, goes down through the venturi, and goes into the engine. But then the pulse comes back up, and as it's coming back up, the venturi doesn't know which way the airflow is going. So the air goes back up through the venturi, some more fuel's pulled out, it comes up above the tubes, and it's sitting there. But pure IR individual runner is a exercise in futility. Plenum chambers are the way to go. But plenum, the volume of the plenum chamber is critical to the carburetor size. And that's where we go here on the 6214, which was the 1150. And to make it try to run, they had they put in what's called an intermediate idle circuit. And so then they decided, well, we'll put that into a 1050, like the 4575, and give it a 1-to-1 throttle linkage. And you got to put everything in historical context here. This was about 1972. Just prior to that, the intake manifolds that had been in fashion were the deep plenum manifolds.
Right.
Okay. And then they found out as they went smaller, they had more throttle response as the plenum chamber got smaller, and then it got down to a mini, what they called a mini plenum. But as the plenum, go ahead.
Yeah, let me show you this, because you're talking right about this question. I think you know this. What are your thoughts on the Budmore intakes? The mini plenum, do you know what I'm talking for Cleveland? They were like a box type intake for NASCAR.
Yeah, I remember. I mean, boy, you're asking me something that I just didn't have a lot of intimate knowledge about. So
okay. I can tell you, they weren't good for the street at all. They only worked on a circle track, and they only worked like 33 grand and above. They had nothing in the low end. Fuel was bad.
What I'll say about plenum is, the bigger the plenum, the old deep plenums, you could run small carburetors on there because the pulse that came up the runner dissipated into the plenum, never went back up into the carburetor, blocked it off. So, you know, a lot of guys run the 2660s, or one of the big cons of all time, because I was in charge of sending the carburetors out to people, was Grumpy Jenkins. You know, he'd tell everybody he's running 2660s. And he had all these articles done on how to modify the 660s. But in truth, he was running 2850s. If anybody went to our catalog, they'd see we had the 660s were part number 4224, but we had 850 center squirters were part number 4223. And he used to tell people that he was putting 850 bases on the 660s. Well, he wasn't. He was running 850s.
I remember hearing that, reading that. Oh, yeah, that's what he did, put the 850 base on.
No, he didn't. He was running 850s, but he was selling 660s to everybody else that was trying to catch him. You know, I mean, he had the reputation of a great carburetor tuner and everything. And he didn't, and he's cutting the choke tower off so nobody could see what the list number was.
Oh, yeah.
You wouldn't know the difference. If you didn't know that an 850 center squirter existed, you wouldn't know the difference. But okay, so that's with deep plenums. Now getting back, the 6214, the 1150 with the intermediate circuit, Chrysler took it and started working with it on the pro stock stuff on the 426 Hemi. Okay, with the Wyand tunneling. And we had to go through a recalibration process. I think it was released as a 6214-1. The original 6214 came with 75 main jets, and then the 6214-1 came with 95s. And it worked pretty decently on a 426 Hemi. But it just lacked something. And the reason it lacked things was because of the inch and 13/16 Venturi. The 1050s were 1 11/16. And quite frankly, the 1050 main body has the most perfect Venturis ever made on a carburetor. The approach angle, the radius, and then the recovery angle after when you come out off what's called the vena contracta, which is the sharp edge there, that's the narrow point. The approach angle was about 11 degrees and the recovery angle was about 7 degrees. And that was perfect. But when you increase that Venturi from 1 11/16 to 1 13/16, that approach angle now goes from 11 down to about 8, and the recovery angle goes from 7 to 4. and it just killed all part throttle, low end part throttle torque. I think I told you when we were talking last week, 1050, a single 1050, if you check the nozzle start and everything, a 1050 will start the nozzles much earlier in airflow than an 850 double pumper. It starts at about the same airflow as a 750 double pumper, which means that the 1050 body, the 45, 75, and what later became the 80, 82 and stuff, they're very good on like a big block on the street. They're an excellent drivable carburetor on those things.
Really?
Okay. Yeah. So what happened was people like the one thing with the 6214, it had the intermediate idle circuit. So they decided to make a 1050 with the intermediate idle circuit. The other thing the 6214 had, because it was an individual runner carburetor, it had one-to-one linkage, throttle linkage. And so we put that into the 6464. I worked on the 6464. It was just coming out as I went to work there, and my mentors were teaching me all about it and everything. And so I got to do a lot of work with it. And you got to look at the time when all this transpired. Like I said, we're going through a very fast metamorphosis of plenum volume. It kept getting smaller and smaller. And as the plenum volume gets smaller, you got to go bigger on the carburetor. Okay. So, but mini plenums were great because they kept a lot of activity in the manifold. That kept tickling the booster, kept tickling the idle circuit to pull the fuel out and everything. And things just worked really good. So the 6464s came out, and we brought those out, and they were originally, I think, shipped with no power valves, and I believe it was 88 jets we had in them.
Okay.
And that was a decent ballpark for what was going on. But as things went on, we started getting a lot of complaints that guys would go up in the jet size, they'd go up to 90, 92, and they weren't seeing any benefit. And I started looking into it because, again, I came in after the initial development was done, but we're getting things ready to release for production and stuff. So I started doing a lot of work on the flow box. And this intermediate idle circuit is fed by a tube that sits in the main well where the main jet screws in,
okay,
where your main amount of fuel goes. Those main body, those metering blocks were made out of zinc. And those main wells were made out of tapered plugs. So the top of the whole chamber was about 166 thousandths in diameter, but then it tapered down so you could pull the plug right out of the zinc, you pull it out freely. At the bottom where the main jet went in, those things were only 147 thousandths in diameter. Now put a tube in there with a restriction. The intermediate idle circuit jet was at the bottom of this tube. Now you've just really closed down that main system. And the fact was the other problem you have in the metering block is you have surface drag of the fuel as it goes through the main well up to going over to the nozzle and everything. There's surface drag along there. That's significant. We made acrylic metering blocks and stuff to watch all that stuff.
Yeah.
And so what we did, we decided to pull those intermediate tubes out, go in there and drill that thing out and open it up. And we, if you really want to make those things work, you take the intermediate tubes out. Those are the two solid plugs in the center of the metering block in the top.
Yeah.
Take them out. You drill the main well out to 180 thousandths, okay? All the way down to where the jet is. You can see the drill bit coming down to where the jet is. Drill that out to 180. Then the angle well that's up towards the top of the metering block. I had a metering block here. Okay. The intermediate circuit was fed by tubes that went in here and here. Okay. They solid on the top, right in here and here. That's your main well, where the main jets are. So you would take this passage, drill it out to 180 thousandths. This passage here and this passage. Then you put the tube back in. Now, if you were to take the tube out today, and I've done it in the field, what you got to do is you got to drill the top of that tube with about 125 thousandths drill bit. It'll break into an opening. Use an easy out to get it turned and pull it out. Then you drill that whole area, and then you can put that tube back in. Now, when you put the two, I think that most intermediate circuits are too rich, but we'll get into that later. And you can reduce that intermediate jet size with some wire or different things that you can, I'll put you onto. But if you put 180, drill that out to 180, then do these angle passage right here. This is right here, and right here. That takes you, that's what lines up. That's what lines up with the main nozzle passages right there and there.
Right.
Okay. You drill those things out to 166. That angle passage and those, and you go clear through into the booster and you drill the whole thing out to 166 thousandths. Now that's how you really improve a Dominator. Okay. And that's true for everything. I've been around carburetor modifications. I have flow tested. I was, like I told you before, I have been very blessed by God about being in the right place at the right time throughout my career. And the flow box we had at Holley that we used, that we developed all these things on, was a flow box that was designed for B29 carburetors. Wow. The thing would flow over 5,000 CFM with fuel at 1.5 inches of mercury pressure drop, and it was altitude compensatable. I mean, I developed carburetors that were used at Pikes Peak and one Pikes Peak and a lot of other stuff. But I have flow tested all sorts of carburetors that have been modified. I mean, stuff that I see today that, and I'm not being disparaging in anything, anybody that's out there. I don't want to come across as disparaging, but we had a fellow tech salesman at Holley when I was there named Ed Hecht out of Texas, and another fellow named Chuck Gulledge out of California. And they did all the nice cosmetic stuff. And they might have picked up at 1.5 inches of mercury, they might have picked up 20 CFM. But at 0.5 inch of mercury, where the thing is running, that 20 CFM is maybe 11. And I mean, it didn't do diddly squat. What you're really worried about is the air-fuel mixture through the operating range. And you get much more performance out of accurately controlling the fuel on the air-fuel mixture than all this other crap about thinning out throttle plates and everything else. There is so much more power to be getting.
So you're telling me that thinned out throttle blades and shafts and button screws and all this stuff, and you're telling me it doesn't do a damn bit of good.
Spit into the wind. Spit into the wind. Yeah.
I mean,
you do what I'm telling you about on a metering block. You do
it. Yeah.
I'm telling you about on a metering block. On a serious 8-second car, it's 0.3.
Say that again.
On a serious 8-second car, low 8-second car, it's worth 0.3.
Wow.
It's in the response of the nozzle and everything else. You minimize all that surface drag because you've increased the volume in the main well. All the crap with the air bleeds and stuff. What a waste of time, unless you really know what you're doing. And think about all the air bleed drilling and all the other stuff. I played with all that stuff on an air box, and I know how it. See, people don't have wet air boxes to play with. And if you do have a wet air box, what fuel are you using? See, we used what was called Rocasol. It was a safe fuel that had the same safe
specific
liquid.
gravity.
It had the same specific gravity as gasoline, and so we could get accurate information. Also, just so you know, I told you I've been lucky being at the right place at the right time. I was very fortunate not going to work at Holley before I did, because they changed to Rocasol right before I got there. And all the people I worked with had flowed carburetors for years and done all this work using benzene. Now, you're in the medical area. Benzene's a carcinogen.
Sure it is, yep.
The people that know all about this stuff and everything that I worked with, they're all dead.
Yeah.
And they all died in the early 80s. I mean, leukemia, Hodgkin's disease, you name it. I don't know how Holley got away without being sued, but I mean, I was lucky in that I was only there 4 years. I used what's called Rocasol for flow testing and stuff. And I'm glad I got out of there. You got to be really careful with that stuff. But anyhow, controlling the fuel is far more efficient as far as, and gives you more power than all the other modifications you can make to not just a 4500. The whole Holley, you take anything from a 750 on up, you increase that main well size, and of course the regular double pumper line and the 4575, they don't have that tube there. So it's easy to take that out. I mean, if you have to plug that up, you can use some double wide shock plug buck. You don't have to have that. You can buy, I think, the brass. You used to be able to buy the brass plugs from Holley. I don't know if you still can or not. But enlarging that main well, again, you take it out to 180 thousandths.
Okay.
Then the angle wells to 166, and then the straight through on the boosters to 166, right through the brass pin and everything, all the way to 166. You won't believe the throttle response improvement.
Now I got to try this. You know, wow, that's amazing.
And so anyway, so we get to the 6464s.
Yeah.
And the as manifolds were changing an awful lot real quick. It was like every 6 months something was changing back in those days, and the plenums were getting smaller. The other thing that was going on were the cam designs way back when. They didn't have the fast opening rates we have today.
Sure.
Harvey Crane started playing around with some real fast, quick opening ramps about 1973, and that made a huge change in what was going on. And we could go to a leaner idle circuit and everything else through these carburetors, keep things cleaner, and get much more throttle response coming off the line. And as that all transpired, we found that the intermediate idle circuit itself was contributing too much fuel. It was going rich in the part throttle. Now you might say, what the hell difference does it make? It's going rich in the part throttle. Well, it makes a hell of a lot of difference. To my way of thinking, the most important circuit in a racing carburetor, I don't care if it's drag or circle track, off-road, I don't care what it is. The most important circuit in a racing carburetor is the idle circuit, because you can do more damage with the idle circuit. You can cause the plugs to load up, all sorts of stuff. You want to keep that really clean. I mean, I told you the story about Vince Cagnazzi's Pro Stock car and Erica Enders and stuff, and testing I did at Charlotte just a few years ago before she ever won her first Pro Stock race. And just leaning out the intermediate circuit on that car got 1300s. 13100s. That was just 5 years ago. So, and that's because the idle circuit, as you're staging, if it's loading the plugs up, you're going to spend 60 feet getting the plugs cleaned off to be able to run the rest of the track. And you know, there's more in that first 60 seconds. But the first 60 feet are more important than anything else on that racetrack. If you got an advantage after 60 feet, guys got to have an awful lot of horsepower to go by you.
What was the story about with Erica Ender's car? They said, oh, it was running this, and you said, I can make it run this. How did it go?
Yeah, I worked at Hyperco. I still do consulting work for Hyperco Springs, which is a division of Matthew Warren Industries. And I designed all the springs for the new NASCAR car. I've designed all the chassis springs for all the Indy cars for the last 12 years. Every Indy car's run our stuff, even though they're not required to, but I've got the confidence of the IndyCar teams. So I developed the first high rate, long life, high load carbon fiber spring. This carbon fiber spring system, if you go on the Hyperco website, you can see it's called Bellows Spring. So we're doing development work with it with Victor Cagnazzi and his team, and Erica was driving. Her and Dave Conley were driving, and so we were at Charlotte doing some test work, and they had run these carbon springs. We didn't have the approval of NHRA. They had run the carbon springs about 3 weeks in a row and had done really well. She had like 2 or 3 runner-ups in some meets. And so I'm watching the car launch. I'm behind the car and everything else, and I'm watching it. And I was worried about how the car was settling down after the launch with these carbon springs. So we get in the trailer watching all the telemetry, and Dave Conley's there, and Tommy Baldwin's the crew chief, and he said, you know, if we could get half a tenth, she could be winning some races. And I said, hell, I can get you a 10th. He says, the hell you say? I said, no. I said, you listen to that car? He says, well, I try to. I said, have you listened to it when she brings it up on and stages it? I said, it's loading up a little bit. She's cleaning she's cleaning the spark plugs off in the first 60 feet. And he says, how would you know that? I said, because I designed the damn carburetor. You know? And so he said, can you do something about it? And I said, sure. So what I did is I took the carburetor. They brought the carburetors in. Now I'm supposed to be working on springs. So I took the carburetors apart, and I just took the metering blocks. I pulled those plugs out like I told you. I drilled the main well down out to 180 thousandths, took these angle passages out to 166, drilled through the boosters to 166, and they had the intermediate circuit in. So at the end of the tube, what I did, I asked asked them if they had any bread ties, you know, the paper ties that are on local bread.
A wire in there.
I got the bread ties out. I clipped them about 5/8 of an inch long, stripped the paper off, bent them, put one end up into paper tube, the other end just let it sit alongside the tube.
Yeah.
Put the tube back in, put some double-aught shot buck on, closed up the hole in the top, put it all back together, and that leaned out the intermediate circuit. And so we went back out. I mean, it took me 20 minutes, you know, to do both carburetors. And went back out, and the next run, she picked up 13 100s. And next week, she won up in Chicago. First pro stock victory.
Wow. Okay, so listen to this. Here we go. All right. So you drill the main well, 180 thousandths. You come in the angle sides, 166, right?
Yep.
And then go through the main where the booster is, 166.
Yep.
160.
166.
Yep. And you're going to tell me you do that on any Dominator, and you better watch out performance-wise.
I'm telling you, do that on any Holley, it's 750 or bigger, and you better watch out. Not only that, but the Dominator, you'll go down on jet size. See, that main well was restrictive. Yeah. So we went, after we did that, we like the 6464s, we were putting 84 jets in it. Okay.
Wow. Now, who thought of this drilling this business? You?
I did. I mean, I worked this all out. I mean, I was looking at the prints. I had people calling me up, telling me they're going from 90 to 95 jets and it's not making any difference. And I started looking at how much fuel can we get through the main wells. And, you know, this is all, it isn't something I tried to keep secret or anything, but I kept it to myself. I kept it to our team. Our team knew what was going on.
Right.
Now, I had a lot of success at Holley. I mean, I got in 1975, I got the President's Award for Engineering Excellence for both the carburetors and the manifold line. I told you I helped break up Holley and Edelbrock. I was the last liaison engineer between Holley and Edelbrock, and
so Edelbrock and Holley were together. They're one company.
Well, Edelbrock used Holley's sales force.
Okay.
They had a marketing agreement, and Holley and Edelbrock used Holley's sales force. Holley had 30 salesmen around the country. 12 of them were what we call high performance salesmen. Edelbrock was a relatively small company at the time. Holley had big facilities as far as emissions testing, things like that. Sure. And Vic Edelbrock was president of SEMA. Jim McFarland, chief engineer. He's a chief engineer, but his degree is in journalism. Mainly, he wrote for Hot Rod magazine, Popular Hot Rodding, and things like that. So they had in a garage with a chassis dyno, and they could run what was called the California cycles, but they couldn't even run what was called a cold California cycle because they couldn't shut the garage door. The garage was too short. So we did part of the whole deal was Holley got 5% of their gross sales, but we would do all their emissions testing for nothing. Okay, so they got something out of it. We did all the emissions testing. So I did all the emissions testing on the Tarantulas, the Torkers, the Street Masters, the SP2Ps, all that crap. And as I told you when we talked on the phone, let's put it this way. There was a manipulation of data that was provided to the California Air Resources Board and the EPA. And at that time in the aftermarket, we didn't know what was going on. We were trying to be very responsible and take any carburetor that was aimed at for street performance and we would come up with a calibration that would meet the federal requirements and everything else. See, well, let's just say the Edelbrocks weren't as good as they didn't do what they said they would. And you know what was coming out at the time was Xerox machines.
Yeah, I remember that.
You know, you got to put all this in context, because everybody has a personal copier today and they think they can do all this. But in those days, a Xerox machine weighed 4,000 pounds and was, you know, 6.5 feet by 6.5 feet. And it was huge, you know, and heavy. And people were finding out, you know, you could copy stuff and everything. And so I got a call one day from Bill Howe at Chevrolet. And he said, "Have you seen the newest issue of Popular Hot Rodding?" And I said, "No." He says, "Well, you better take a look at it, because you're going to be in some hot water." And I said, "What do you mean?" He said, "Go get a copy of it, look it over, and then let me know what you think." Well, what it was tests on the Edelbrock Street Bastard manifolds. And we'll say somebody there at Edelbrock published an article in Popular Hot Rodding and put copies of all the data that was submitted to the California Air Resources Board, and they didn't understand you better be able to go down all these numbers, and they had a correction factor, and it better come up with the numbers at the bottom. Well, all the good numbers were under the Edelbrock, except they didn't add up with the column. The numbers for the OE Chevrolet ended up as the good numbers that were under the Edelbrock, and the bad numbers on the Edelbrock column, they ended up under the Chevy OEM. So somebody had switched stuff using a Xerox machine. So I went to our legal department. Our legal department, like I said, I was the last liaison engineer at between Holley and Edelbrock. And they said, "Well, you better go out to Edelbrock and discuss this." So I had 120 emissions runs in my briefcase, copies of 120. This is before you had Excel files. So I had to have this all done myself on paper, you know, spreadsheets on paper with all this crap. And so we got into a heated discussion in Vic's conference room. And they were just south of Los Angeles International Airport in El Segundo at the time.
Yeah. And
by the time I got back to Warren, Michigan at Holley, we no longer had a working agreement. And next morning I was called into the president's office, and he tried to be real stern with me. You know, "What the hell did you do out there?" and all this other stuff. Well, he's essentially the guy that sent me. I mean, the vice president of the legal department sent me, but the president sent me.
Sure.
So he said, "So what are you going to do about this, Campbell?" And I said, "Whatever you want to do, sir." So he says, "I think we better get into the manifold business." And so I was put in charge of developing the first 16 of the Holley manifolds. It ended up I developed the first 18. But I told you that year when we went to SEMA, we hoped to sell a total. We had about 12 or 13 part numbers ready to go. We hoped to take orders for 2,000 manifolds. And we got to SEMA and we got orders for 20,000 small block Chevy Street Dominators alone. You know, it was unbelievable. And we had all the right tooling and all the right money to do it. I mean, we used 4-gas analysis for full throttle testing when everybody else was using thermocouples. Thermocouples don't tell you diddly other than you're close to melting down a piston. And we used, our foundry was Winter's Foundry. People thought the W and Snowflake, you know.
I have a Dominator with Winter's Foundry on it.
Yep, Winters. Yep. They had top-notch tooling, top-notch. They were the best aluminum casting facility in the United States.
The ZL1 motor came from there. The Chevy ZL1.
Yeah.
Yeah, Snowflake.
Yeah, and all those heads, the L88 and ZL1 heads, all came out of Winters. And of course, the Z28 manifold and the LT1 manifolds came out of Winters. Okay. Matter of fact, the Holley small block Chevy stuff used the Chevrolet tooling as far as the locators and everything for how they machined the manifold. That's why they were so accurate. But
so you designed the Holley strip dominator for Cleveland, 351 Cleveland.
Correct.
Nice. You know what? I don't like the Plenum. Like when you look
you got to put everything in context. You got to understand. It's just like what I was telling you. These things were designed to be able to fit under the hood or with a minor hood scoop of the vehicles of the day.
Right.
You know, and you got to understand I was under a lot of pressure to get 12 manifolds out in 18 months. Okay, the first 12 had to be done in 18 months, and I think that was number 13. I think we got it out. We were able, with that air box, we could flow the manifold. It would flow carburetor manifold. We could even float with heads, okay, with fuel. So I mean, we had advantages nobody had in the industry.
How many dynos did you have? How many dynos were you running?
We had a lot of the dynos would run 2 engines at a time. They were eddy current dynos, and so you had 2 engines hooked up. If you talked about engines tied up, that you could run at a time, we could run 24 engines at a time. But most of the development we did on the manifolds was done on a Heenan-Frude dynamometer, okay. And that was the standard at the time. That's another issue. I mean, we get into. I mean, it's called brake horsepower, and what brake horsepower means is you pull the throttle all the way wide open, and then you adjust the load. Let's say you want to see what the horsepower is at 5,000 RPM. You adjust the load on the dyno. It was a water brake. You adjust the load so the thing's sitting there at 5,000 RPM. The damn engine has its tongue hanging out, and it can't go to 5,001. It can't go to 5,002. It's sitting there at 5,000, and you're reading the torque. You got the RPM, you read the fuel flow, and you can figure out what your brake specifics are and everything else. And that's an issue I have with a lot of dynos today, because you got a computer algorithm running the thing. The thing's always going up. It's never at a break, and people, you got to think about all this when you're building an engine and the cam selection and everything else. Is the engines, if an engine's accelerating, it's not running at full throttle, not running at maximum horsepower. It's running between the horsepower it needs at that mile an hour and what the residual horsepower is up to the peak. So there's a that allows it to keep accelerating. And I just have some issues with the algorithms that are used that show what the horsepower is on current computer-controlled dynamometers. I'm not convinced that they're 100% accurate. They're good ballpark. They're good tools. Sure. And a dynamometer, sort of like an air box, is better to work with, especially if you have fuel. That's working without fuel would be really difficult for me. But an engine dynamometer, I pulled to handle hundreds, thousands of runs, and I'm convinced that if you don't understand how a dyno has to be set up, I mean, airflow into the dyno cell, positive extraction on the exhaust, all the stuff that goes with it, a dynamometer can be the worst tool in your toolbox. It can take you down the wrong road if you don't know what you're doing and really understand it. Fortunately, I had a lot of good people teaching me all this stuff, and a dyno can really I've seen a dyno take people just down the wrong direction so many times.
Let me ask you this, Mark.
Pardon me?
We kind of went off on a digress.
Yeah, let's get back to 6464s.
So yeah, let's go back there and we'll kind of come back this way.
Okay, the 6464s were great because they had the same venturi and everything as a 1050, this perfectly formed venturi that really generated great low end torque. And like I told you the other day, they had an old eyebrow booster, and that booster was really good booster venturi. And after I left and after the guys in my team left, the people that came in got rid of that booster, and they started really being consumed with the annular booster. And the annular booster is a fantastic booster for low airflow speeds, like what you see on drivability on the street on a car.
Yeah,
annular booster venturi is super for that. But at high airflows at low vacuums across the carburetor, the annular booster venturi is not anywhere close to what was in the original 4575 or 6464s. Those were the best boosters, and we used that booster in the 8082. The 8082 came after the 6464. And what happened, we had a lot of people with 6464s that didn't like the one-to-one linkage. It made it tough driving through the pits and everything else, and especially as cams were going where people were shortening up the duration a little bit and going more lift. shorter duration to get more throttle response. They liked a certain amount of staged linkage. So we came out with what we call a 3-stage linkage on the 8082 that opened a little bit and then brought the secondaries in slowly to a certain point, and then everything came in at about 40% of throttle opening. Everything came in together. The 8082, what we did with it, at the factory, we drilled the main well out to 166. We didn't take it out to 180 because manufacturing people weren't sure about the wall thickness in the metering blocks. They were worried about porosity and stuff like that, and something breaking through. So the 8082s from the factory had all the passages at 166, the angle passage and into the booster ventures at 166. And they were really responsive. And what we did is we changed the idle circuit. When I say change the idle circuit, we changed the height of the transfer slots in the body of the carburetor on the 8082 so that they worked sort of like an intermediate circuit. More as you open the throttle, they provided fuel sort of like the intermediate circuit did, a little bit of extra richness there, make it easier to stage with pretty big cams and low manifold vacuums and stuff like that. And it kept things cleaner in the idle circuit, especially as the plenum volume was dropping even more and more. And so they became very big about 1976, just about time I was leaving. And I guess I got to say something there. You know, I left in 76, and the reason I left, I told you the other day, is we had such success both in carburation and manifolds that the hierarchy at Holley decided they'd poured all this money into all this development and everything, and to get stuff to market in a hurry, and they wanted to get their profits out of it. And so they told me, they said, we're going to quit doing any development for the next 2 years. We got enough of a lead on everybody. We're going to quit development for 2 years. We want you to go down to our manufacturing plant in Bowling Green and learn about manufacturing and stuff like that. And you're on the fast track to Mahogany Row and all this other crap. Well, sure. Mahogany Row didn't interest me. I like dynamometers. I like gearboxes. I like making power and seeing what I could do. So I left in 1976 and went to Gale Banks Engineering out on the West Coast and did turbocharger package for his marine engines. And we developed a package that got certification on his turbocharger packages that Chevy, it didn't compromise the Chevy warranty on marine engines. But what happened also during those 2 years is my team broke up. And a lot of the guys they essentially broke up the high performance team right after I left. And so a lot of those guys that understood all that we're talking about here, they dissipated into the company, and some of them went to Ford, some of them went to Chrysler. You have to understand it was wage price controls with Nixon back in those days. And the only way you could get an increase in your pay was you had to leave your company and go someplace else where you could get more. So that whole team, which was a great team that I had, it all dissipated. And then about 4 years later, they tried to bring some people back in to reconstitute the team, and they didn't understand what was going on. And they didn't understand these limitations in the metering block and all the other stuff that goes on. That just, if they wanted to research it, it was there because I had it in notes, and we had to put stuff in engineering notes, and it was kept in a building called the morgue. But people just didn't have the initiative to go look all that stuff up.
Wow. Now, I remember you told me about, was it the 4575 that you helped work on, where you had they were giving you another engineer, 3 technicians, and 3 dynos? Remember?
No, that was the manifolds.
Okay.
That was the manifolds. This is 1973. They gave me $250,000 to spend on engines and camshafts and headers and everybody else's intake manifold to evaluate it. Just real quick things there. You have the salespeople. You got to understand too, the hierarchy at Holley at that time, they all were typical Detroit business people. Even when I was there, I had to wear a sport coat and tie. I could take the sport coat off while I was working on the engine or in the airbox, and I'd put my tie inside the shirt so I wouldn't get stuff on it. but that was just the rules. If you had an engineering title, you had to wear a suit or a sport coat and ties and everything, even though you're working on a car. So, I had lab coats that I'd keep things clean. But anyway, we early on with the strip dominator for the small block Chevy found that the runners needed to have about a 15 to 17% decrease in cross-sectional area from the plenum to the port. Okay. And that was when we found that out, that was huge, because Edelbrock was putting, Jim McFarland thought it would be really neat to put a Venturi into the intake manifold runner. How stupid, whenever you have a Venturi, the friggin', you got a pressure drop across there. So your air density isn't as strong into the cylinder. So it was easy to beat them with power. And then he did all sorts of stupid stuff, like he'd turn the carburetor at an angle on the big block Chevy and the Ford. On the little Ford engine, the 302 with their torquer. With our street dominator for the 302 Ford, what we did is we cut the damn torquer off, cut the carburetor plate off, put it on square, welded it up, polished it up, picked up 18 horsepower.
Wow.
Pontiac torquer. He would do things to make people think it was scienced out. He had a floor in the bottom of the plenum of the Pontiac torquer that looked like stadium seating. I mean, it was over half an inch in the front half of the plenum was a half an inch deeper than the back half. And the front four runners were tall and thin, and the back runners were shorter and fatter, Well, when we floated, the back runners flowed like gangbusters, and the front runners flowed like crap. And one of the things we did, we just took a bunch of DevCon and filled in the whole floor of the manifold there where it was all cut out. We picked up on the dyno 43 horsepower. 43. Can you imagine how bad that manifold was? So then what we did, what the Holley Street Dominator for the Pontiac is, we took two torquers, cut them in half, took the rear runners from one, made them the primary runners, just welded it all together, ground it all out. That was our prototype, put the water crossover on there. And that manifold worked like gangbusters. The people who ran Pontiacs loved that thing.
That's hilarious. I love that.
But we did that, and we said, well, we got, we're way ahead of everybody else on this, and we didn't even put any effort in it. So we'll just get this out and get it to market, and then if they catch up, then we know other things we can do that'll put us back ahead. But then they disbanded it.
Somebody asked this question, Mark, and I have an answer for it. If you don't, can you read these on the screen? Do you see that?
Why did Holley stop making the strip dominator intake for the 4-barrel Cleveland? I can only assume that it was sales dropped off. That's all.
Yeah,
interesting.
That's exactly right. It became less popular motor. No one was racing it like they used to. So I remember when I went to buy it.
The fact was those damn Cleveland heads were so good. The 2-barrel heads were good. I got a friend, as a Cleveland aficionado, you'll appreciate this. I got a friend, his name's Lewis Robertson. I think he still has his place. It's called The Shop in down in near Norfolk, Hopewell, Virginia. Lewis Robson, one of the sharpest engine builders I ever met. I mean, he's up there above Bill Jenkins and other people. This guy was fantastic, but he, like me, kept to himself. Anyway, where was I going with all this? Oh, he built an engine for GT3 racing down at Daytona, the 24 hours and stuff like that for David Hobbs. And Ford was wanting to use the Boss 302. So he did a bunch of dyno work on the Boss 302, and those ports were just so friggin' huge. So what he did, he took the heads off of a 351 Cleveland 2-barrel, and he cleaned them up, did a nice valve job on the port and everything else, put them on the engine. They went down to Daytona, and he was they were 5 seconds a lap faster than the other Boss 302s down there. They were 3 mile an hour slower on the back straight, but coming through the road course and everything, so much faster off the turns. They were 5 seconds a lap faster than the others.
Oh yeah, there's no doubt about that. Let me just put this up. Now I'll check this out. And this is what you're talking about.
Yeah.
Now the difference is the Aussie 2-barrel Cleveland heads have a 4-barrel Cleveland combustion chamber, a quench combustion chamber, but with a 2-barrel size intake and exhaust.
Well, that's perfect. That's perfect.
They're a killer set of heads when you work them over, Joey.
Well, people, the thing there, the whole reason quench chambers went away was emissions. When you have a quench chamber, it causes the unburned hydrocarbons to be high. So you had to get rid of the quench chamber to reduce the unburned hydrocarbons. And Australia wasn't worried about that. Quench chamber is the way you make horsepower. You want, because people, I don't know how many, fuel doesn't explode, it burns. And what detonation is the pressure wave is increasing the pressure on the unburned fuel, so that temperature's going up, and detonation occurs when it finally explodes uncontrolled, doesn't burn. Well, the whole purpose of quench chamber is you got this high pressure wave going across there really fast, burning fast, and just about the time it's ready to explode, it hits that cool cast iron in the quench chamber, and the fire goes out. You don't get any detonation.
Okay. Tell me about what you thought about the 4575 and the Boss 429 stuff, both NASCAR and on the street. I remember you mentioning it really wasn't good on the street.
Well, the 4575 was good on the street.
Okay.
But the problem with the 4575, it had a really rich idle circuit in it. And if you leaned at the idle circuits, the idle jets on those they're a brass plug right here and right there on the metering block, right? Can you see it right there?
Yep,
and right there.
Yeah.
And they were 43 thousandths in diameter. Okay. So what you do, you got to use something a little bit bigger than a tie wrap. You get some wire about 18 thousandths in diameter, 16 to 18 thousandths in diameter. Just cut it about 5/8 of an inch long, put it in that brass tube, put the other leg right down into this open hole right here, put the gasket on it so keep it in place. That'll lean out the idle circuit, and the thing will drive like, it's just so nice.
Good little tuning fix right there.
Oh yeah, and it'll keep your plugs clean and everything else. Yeah, and then they drive really well. I had a customer when I had my shop I had an engine building shop in Monaca, Pennsylvania. That's about 30 miles northwest of Pittsburgh. I had it for 25 years. And I had a customer with a 455 Pontiac that we put an 8082 on, which is an 8082 is just a 4575 with, again, the main well is all drilled out and everything else. And he just loved it. He couldn't believe how drivable it was and everything else. I mean, the only problem is you can't drive it too well in the winter. It didn't have a choke and stuff like that.
Now they did have chokes though, right? The original 45.
For the 4575. The 4575 had the provision for a choke. Yes, it did.
Yeah. Even for NASCAR, they had a choke on there to warm them up. I thought I saw them on a NASCAR. Okay.
Well, most of the people for NASCAR ended up pulling that choke plate out. I mean, they didn't want to take have an accident in case of it closing up and going rich on them, so that they would take them out. But it was there to say it was streetable, and it was. What happened was, prior to 1971, all the original Holley double pumpers and like the 4575, those were developed out in the field. And one of the main guys that did that work was a fellow by the name of Ralph Johnson. He's the father of the Holley double pumper. Ralph, I live in Ormond Beach, Florida. Ralph lives down here about 8 miles from me in Holly Hill. And Ralph is probably, I'm going to be 75, so that means Ralph's got to be 85, 86.
Wow.
So he was Smokey Unique's right-hand man after he left Holley.
I've heard of him.
They went down and worked for Smokey for years. And I never met him till I closed up my shop and went to work at Crane, and he ended up being my main technician at Crane Cams. And our paths had crossed, but we never made, never met each other. But anyway, he developed the double pumpers and everything. He put a general package together and of air bleeds and jetting and idle feeder station. He made everything really rich, and he said, "There, make them." And Holley did. And back in the '60s, they had a reputation of fouling out spark plugs and being undrivable and stuff. So when I got to Holley, I looked them all over, and their warp rate at the time was 8% on most all those different carburetors. But they didn't make competition. Nobody else made a double pumper, so they just kept making them and make these better. And they said, well, the only way you can make them better is if you make them cheaper. And so what I did is I designed that linkage that uses the little link on the side. It used what was called an overhead linkage that had bearing in it, big heavy throttle, whatever, that was on all the double pumpers. And the problem was it didn't operate in a line, and so everything was always on a bind.
Okay.
And so I got rid of that and came up with this new linkage that they still use. And I was able to take, back in those days, one of those carburetors cost about $28 to make. I took about $3 out of it with that linkage change. And then what I did at the same time is I recalibrated and put a streetable driving fuel curve into them so that they could be used on the street much easier. So we ended up making a lot more money because I took all this money, the cost savings out, and the warranty rate went from over 8% on each part number down to less than 1%. And then, so it was a huge win.
So you're saying they didn't care about 15% warranty? Didn't matter to them.
Nope.
They
put it right into the price and jacked the price up.
Not worry about quality.
Huh?
Not worry about quality.
Well, the quality, the parts was there. It was the quality of the fuel calibration was for crap.
Okay.
So like I said, I've always been a workaholic, and anything I was tied to, I wanted to make sure it was as good as it could be. So put good fuel drivable curve into those things, and that also went into all the spreadboard double pumpers and stuff like that. But at the same time, starting in '71, you had federal emissions laws coming in, so we were developing the carburetors so that we wouldn't incur the wrath of the EPA and everything. So we were doing everything we could to lean them out, make them as compatible as we could with different things.
Yeah, someone who said that, Dean Stevenson, a guy on here, a subscriber, said that about the EPA was kind of running the show, controlling the way they were made. Everything had to meet the EPA regulations.
The EPA didn't know what they were doing. Okay, they didn't know how to handle
They still don't.
They didn't know how. Well, what I meant is they didn't know how to handle the automotive aftermarket, particularly the performance aftermarket.
Okay.
And one of the great things, they came out with a rule saying you can change a carburetor, but you can't take a 2-barrel carburetor off of an engine and then put a 4-barrel carburetor on. They didn't even understand that you needed a different intake manifold, but they just came out with a law. You can't do this.
Right.
So one of the things I got to give Vic Edelbrock a lot of credit for, he was president of SEMA. He got California Air Resources Board to put through a thing where you could change any OEM manifold for any aftermarket manifold. Okay. And he stipulated that if it had EGR on it, which was big in '73, '74, all that time. You had to replace the stock manifold with one that had EGR. Okay. So, okay, great. But what it did do is they didn't say you had to replace a 2-barrel manifold with a two-barrel manifold. They allowed a 4-barrel manifold to go on. Well, once the 4-barrel manifold was allowed to go on, then that opened up the everything that we could put a 4-barrel carburetor on, as long as it could pass the emissions test. And we came up with a whole line of carburetors that were called emissions performance carburetors, that passed the federal tests and everything. And then what I did when I designed all the Holley Street Dominator manifolds came with 2 cup plugs, like freeze plugs, right? And if you look down in the manifold, there was a ledge in there. And what you would do, we couldn't write it. We couldn't write it into the instructions. But if someone paid attention to what they were doing, you could take those 2 cup plugs, put them right down into the EGR passages in the manifold, tap them in, and then you could bolt the EGR manifold right on top of them, hook the vacuum hose in, and the EGR valve would work, but nothing would happen.
That's great.
I take great pride in that. All the Holley Street Dominators, you could put
Innuendo.
And
Innuendo.
Yeah. We just, we'd tell people about it, at different seminars and stuff. And
well, you can lead the horse to water.
Huh?
You can lead the horse to water.
Yeah. And hopefully people would catch on to it,
What do you think? I don't know. Somebody's asking here. I'll put the question on here and then you read it and tell me if you know anything about it. What's up, Greg? Good to see you. Yanks?
If you don't have a wet flow air box like I had, it's pretty hard to make a really good carburetor. He was tied in with a fellow that used to work at Holley in the catalog department who started Quick Fuel, Marty Brown. Okay, I don't know if you knew Marty Brown or not.
I know Quick Fuel, but I don't know Marty.
Yeah, Marty helped start Quick Fuel. And the whole Barry Grant thing, I'm glad I was never associated with it. It was a stain on a lot of people's careers. A lot of people ended up losing their job, and there was a lot of bad crap went on there. So I'll just leave it at that.
No, I hear you. I'll tell you.
And all I'm going to say, like I said, it isn't that I'm a smart guy. I was in the right place at the right time. When I first went to work there, I had all these people who had been involved in all this stuff their whole lives, who were nearing retirement, and they taught me. They passed on all this stuff. Plus, I worked my ass off. I mean, I spent every spare minute either on the airbox or the dynamometer. And we had just the best facilities you could possibly have. Nobody came close to us in the aftermarket. And it's just a case, if you've got cubic money and cubic facilities,
yep,
you can really make a quality product if you put the effort into doing it. Now, the problem I have is after I left and they disbanded the high performance unit for a few years, all that knowledge dissipated. And they brought people back in who didn't know what was going on. And about that time, Holley had always had a fuel injection program going on. I mean, from the 60s, Holley had always been developing fuel injection. Okay. Fuel injection there's no horsepower benefit of fuel injection over carburation if you're talking not naturally aspirated. I mean, there's benefits in fuel injection if it's for street use, if it's computer controlled and you can shut fuel off on deceleration and stuff like that. There's lots of benefit. But for horsepower, there's no benefit. And that's why Ford kept carburetors on their police interceptors while they were running fuel injection on their regular street cars. But anyhow, long about the late 80s, Holley sold their business off to Ford Warner and others. Okay, and they split the company up, and the automotive aftermarket department went down to Bowling Green. And the problem was Bowling Green. Most of the people didn't want to go to Bowling Green. I liked Bowling Green. Bowling Green's a hell of a nice town, but people didn't want to leave their families up in Detroit. So the high performance group went to Bowling Green, but nobody knew anything. Nobody had any experience. They didn't understand all these limitations. They didn't understand why things were done. They took this, what we call the orifice airbox. They took it to Bowling Green, and as far as I know, it's still sitting in crates outside the Bowling Green manufacturing plant. They never bothered to put it up. The biggest airboxes they have flow about 550 CFM with fuel. You've got to understand, fuel takes up about 15% of the airflow. You know, I mean, a lot of people don't realize that when you dry flow it and you say it flows 250 CFM, if you put fuel in there, fuel's going to take up 15% of that.
Stop there for 1 second, Mark, and read this.
Okay. Yeah, that's absolutely correct. That's absolutely correct. Like I said, and golly, I told you that when we talked on the phone, and I'm not saying this across the board, but there were a lot of people back in the day with the car magazines. It isn't like you got the internet and can go on stuff.
Right.
But I told you there was fraudulent data submitted to the California Air Resources Board. Okay.
Yeah.
And that wasn't found till 1992. That went from 1972 to 1992 before the ARB and the EPA found out how to read their own damn emissions tests. Okay. Shame on them. But there were a lot of exaggerated claims on a lot of that stuff. But like I said, yeah, if you're flowing it dry, you're flowing one venturi at a time because that's all you can do, you aren't going to get a true picture of what the thing can do. I'm going to die soon, so I don't have a terminal disease, but I am 74. So might as well pass it on, whatever I can do.
Here's another one.
Well, that's nice to see. Gurney for president. I miss those upper stickers. That was a big deal in Car and Driver magazine back in the day.
You know what? I never even knew what it was until you just brought this up. I've never asked about it.
You didn't know that? Oh man,
No.
Car and Driver. Brock Yates he used to be promoting Dan Gurney for president. I think for probably 1968. And there were it was right about the time they did the first Cannonball run. Okay. When I was the liaison engineer between Holley and Edelbrock, I used to fly out to Edelbrock for 3 days, every 3 weeks. And I stayed at the, what's the Motor Inn there in Redondo Beach, where the Cannonball rally. I'm having a senior moment.
Holiday Inn, Motor Inn.
No, it was owned by a gal by the name of Mary Smith. She had been a driver in the mobile gas economy runs for years. And all the racers, when they raced at Riverside, the Portofino Motor Inn, okay, in King Harbor at Redondo Beach. And I would stay Oceanside first floor room all the time. And I'd go out there for 3 days, every 3 weeks, and do all this stuff. But that was just a great time. Now, what was that?
I forgot too, because I got into just talking and listening.
It'll come back. Oh, we're talking about Gurney for president.
Yeah.
Brock Yates, when he did Cannonball Run, they ended up at the Portofino Motor Inn. But he, in 1968, as part of the whole Car and Driver thing, that was a great magazine back then. They had what they called the boss wagons. They had a Chrysler wagon, and they had a Olds Cutlass wagon, and they had some really nice cars that they had. But he was on pushing Dan Gurney for president about the same time that the Smothers brothers were pushing Pat Paulson for president.
That was like 70 or 71.
I think it was 68.
Okay. I can remember Smothers brothers.
Yeah.
Laughing. Remember Laughing?
Yeah.
Oh, my God. But I see Gurney has a Boss 302. I'll just put it down here. He has a sticker on his Boss 302.
Very nice. Very nice. That would be so cool.
Here's one for you.
No. That was one of the things the 4500 showed up was that the power valves that we had at the time, they had 4 holes in them on the backside of the power valves. And they only flowed enough fuel to fill a 55 thousandths power valve channel restriction. The power valve channel restriction is this hole right here. The power valve screws in right here. The power valve channel restriction is this hole on these 2 holes on either side. They're in parallel with the main jet. So what a power valve does, it's a vacuum switch. When the vacuum drops below a certain point, these parallel jets come in with the main jets and supplement the fuel. So your total fuel flow at full throttle is the diameter of the main jets, plus you have to figure out that area. You can't go by diameters, you got to go pi r squared, the area of the hole, plus the area of the power valve channel restrictions. And the power valves we had would only fill a 55 thousandths orifice. So I found that was a flow restriction, and then we came out with what were called picture window power valves.
Yeah.
Well, the picture window power valves were good up to about 78 thousandths. So with the Dominators, we needed even more flow. With some Plenum rams, we needed even more flow. So we took out the guts internally, and we were able to get those things to flow up we could make these things 93 thousandths. So you had maybe a part throttle would run like an 84 jet, and then you had 93 thousandths on the power valve channel restrictions, and then you had plenty of, and then with the main wells opened up, you had plenty of fuel. The key to making these things work is you've got to open up those main wells. That's the restriction on all this stuff. And that's, like I say, everybody's carried away worrying about the airflow into the friggin' carburetor. It doesn't mean diddly squat. It's control of the fuel.
I've never ever heard that. I've never heard anybody say drill the main wells out.
Think about this. It's fuel-air ratio. Which weighs more? Fuel.
Fuel. Yeah.
You got any little thing you do to the fuel has a hell of a lot more effect than all the little crappy stuff you do with the air as far as the bleeds and stuff. It's all in the fuel.
Fuel control, not air control.
Right. Ideally, I never like to run an idle feed restriction. A total area. Now, whether you do this with wire and whatever, the little brass jets that go in there, I never ran idle feed restriction more than 0.037. And most everything I did with race carburetors was 0.33 to 0.35. I never needed more fuel than that.
You just put the wire in there, bend it up, put the gasket over it. It's good to go.
Yeah, you got to get, what you need to do is get yourself a twist drill chart of all the numbered drills.
Yep.
And they give you the area of what it is. And you have to figure this all out by the area of the charts.
Got it.
The area of the sizes.
Yep. Whatever size that is, you look at the area and kind of correspond to it.
Yeah.
Here's an interesting one. I'm not sure what to think about it, from Dean Stevenson.
Oh, that's all BS. Holley always did everything wet. And that the reason they did everything wet, that was a standard in the industry. That if you go to the SAE manuals, all the stuff about how to flow a carburetor and what pressure drops you use, that was all stated in the SAE manuals. And you did everything according to SAE. Otherwise, you had liability issues. And that's one of the conventions too that's out there. See, single barrels and two barrels are flow rated at 3 inches of vacuum underneath the throttle, wide open throttle. In other words, you have the carburetor and you're sitting there and it's on the flow bench and you got all 4 boards are wide open, okay? And then you increase the air pump, the air box, so that you got 1.5 inches of mercury vacuum. That's 21.4 inches of water.
Where are you reading that? Above the carburetor?
No, below the carburetor.
Okay.
In the plenum.
Yep.
You read that in an adapter that this is sitting on. You read that vacuum.
Okay.
And so
you just keep turning it up until that vacuum is at 1.5.
1.5. 20.4 inches of water. It's 13.6 inches of water per 1 inch of mercury.
Okay.
So this is another thing that there's all BS about. A 500 CFM 2-barrel Holley does not flow 500 CFM compared to a 4-barrel. It flows 500 CFM at 3 inches of mercury.
3 inches.
At flowed as a 4-barrel, 1.5, it only flows about 350.
Okay.
To get what the rating of a 2-barrel is to a 4-barrel, you got to divide the flow rating by the square root of 2, 1.414. And the reason of that is you have your rated flow, 3 inches, but what it really ought to be is a 4-barrel is 1.5. 1.5 goes into 3 2 times.
Yep.
But it is the square root of the difference. So the square root of 2 is 1.414. So you take 500 divided by 1.414, and that's what a 500 CFM 2-barrel flows. Same with like the 600 CFM 2-barrel. Which brings, if you really want to know how things got screwed up with Holley, that'll take me into another thing. The guy that I knew that knew the most that I, in my time of really following this stuff, so I can't tell you who's the best at doing carburetors right now. I mean, I do some every now and then, but pretty much I try to stay away from it.
Yep.
Because I rather play my saxophones. But anyway, the guy that really had his crap together was David Braswell.
Braswell, yeah, I've heard that.
Okay.
Yep.
And the story, so here's the story. This is background. 1971, David Braswell takes 500 CFM Holley 2-barrel. There were a lot of circle track classes that they would call limited late model and things like that, where they would build them up like a late model engine, but to be a little bit save money, they'd run a 2-barrel instead of 4-barrel. So he'd take the Holley 500 CFM 2-barrel, and he'd take out the booster venturis, drill out the venturi, and put an insert in that had an annulus in it with discharge holes. So there was no booster in it, okay? And with a relative, he called it a 650 CFM 2-barrel, but it really wasn't. It was about 625, and let's see, 625 divided by 1.414. It flowed about 442, okay? Now, just as I came to work at Holley, getting all these calls about these Braswell 652 barrels, and they're the hot ticket. Well, our salespeople couldn't stand to have someone modify a Holley that really made an improvement, and Braswell did. So they sent this same guy that was big on the 4575, Bud Elliott, that I told you about.
Yeah.
Sent him out to Tucson to Braswell's place, and he bought 3 of them. He said he had a bunch of circle track cars up in Minnesota. So he buys 3 of them, brings them home. We go through everything. Within 90 days, we're in production making the same damn thing. Okay. So Braswell has patent pending on all this stuff. Well, and he was applying for a patent on his carburetor. The problem is, this is where there's nothing new, And I've read all the engineering books. One of the best engineering books that still holds water today is Sir Harry Ricardo's book on the internal combustion engine, written in 1927. Okay. Well, it just so happens annular discharge carburetors were available in 1927.
Wow.
So Braswell's patent was invalid. But if you're dealing with patent attorneys, you don't find that out. I've been involved with patent attorneys and everything. So all a patent does is if you get a patent, it allows you to sue somebody. And then when it goes to court, you find out if there's prior knowledge on it, stuff like this. Well, the prior previous art was clear back to 1927. I mean, you're talking almost 50 years at the time Braswell's coming out with this stuff. He didn't know that. He didn't know that. And Holley, he sued Holley. Well, Holley had their own legal department. I mean, the head of the legal department was a patent attorney. He knew it was all BS, but they wouldn't tell him that. They drove that poor guy into bankruptcy. They just let him spend his money, tilting at windmills. So he's pissed off. So he starts having a problem. Financial problems, whatever. I didn't follow it after that.
Yep.
Let's fast forward to about 1996. Nobody at Holley knows anything about carburetors. They're making carburetors, but they don't know anything about it. The dies that they had were worn out. The dies for the main body, the cooling tubes inside the dies were all plugged up with calcium and all the, they're just plugged up, like a radiator gets plugged up. So they decided to have things retooled. That's a whole different story anyhow. But they retooled these things, and then they had to recalibrate. They decided they were going to come out. This was the HP series of Holley 4500 product. Yep. Okay. Nobody really knew what was going on. So they decided, Jeff King was the president of Holley at the time. They decided to get the most experienced, the guy with the best reputation in the country to do the development and the calibration of all these HP carburetors. So who'd they get? They got David Braswell. And they didn't realize that David, you talk about wanting to put it to him, had an axe to grind for 25 years.
Yeah.
So David Braswell developed all these. I told you the restrictions that were in the main wells and everything. Yeah. He made them even smaller. He made them more restrictive. Okay. And the whole idea was, once you bought one of those HP carburetors, then you could send it to him, And, you know, for a few $100s, he'd tweak it up and get you the maximum performance out of it because he had done, you know, it was a general format for the public to work with. So, and I'm telling you what, I told you the guy at the 455 Pontiac that had the 4500 on.
Yep.
What I got him was an 8082. It was one of these new HP carburetors. This car would run, it would run 1020s. It was a bracket racer, Firebird. It'd run 1020s all day long. And I told him he could get into the nines with 4500. So I give him this 8082. He puts it on. Damn thing went like a 1060. I mean, it wouldn't fall out of a tree. And so he brings it. He's, you know, because he'd asked me, what should I do? I said, just run it out of the box. You know, I did the original calibration on it. If they kept all the paperwork, they ought to be okay. Well, they hadn't kept the paperwork. So it isn't running worth a damn. He brings it to me, and literally, there's no BS, literally half an hour, no longer than half an hour. I went through the whole carburetor, put it back on. He takes it out to Quaker City Drag Strip out there in Columbia, Ohio, the next week. 980. Went from 1060 to 980. Just because it was all restricted in fuel. And I mean, but you know, Braswell, God bless him, he made a bunch of money off of that and all those HP carburetors. But the people, so I called up Holley to tell them they had a major problem. And it took me a long time to get a hold of Jeff King. And I said, you know, you got a real problem. I said, I hear you had Braswell do these. So then I related to the whole issue, the history of what happened with Braswell back in the 70s. He says, oh my God, we didn't do that, did we? I said, yeah. He says, well, I'm going to have my engineering department, you know, call you up on this. So the engineers called me up. And this one guy in particular, he said, I said, what's your position? He says, I'm in charge of high performance carburation. This is like 1996. I said, how long you been doing that? He said, 25 years. I said, the hell you say? And I said, 25 years ago, I was there and I was in charge of it. I designed the damn carburetor, you know? He didn't know, and he had worked for Holley in the manufacturing plant. I didn't know who this guy was from Adam, and he was in charge of carburation. And that's been one of my great frustrations at the PRI show, going to the Holley booth and talking with those guys. Getting frustrated for the lack of knowledge. But anyway, I explained to him what was going on, and he insisted that there wasn't anything wrong with those, that they had flow tested them. I said, well, you can only flow test to 550 CFM. And he said, well, that's true. I said, so you don't know what's doing beyond that. You don't know what the flow limitation is. You know, you can extrapolate out what the airflow would be at a certain thing. There's mathematical equations. You can extrapolate all this out. You can use a little air box and flow one Venturi at a time and then extrapolate what it would be at 1.5 inches or something like that. That can all be done mathematically. But it doesn't tell you what's going on in the metering box or at the booster Venturi.
So I got a question. Go ahead.
I don't know how they worked that out. I more or less gave up on them at that point.
Check this out. Tell me what you think here.
I always liked cross rams, you know. I liked the idea of them. I thought they were neat. I only worked on a couple of them and they were Edelbrocks, and they were on 390s. The key there is if you're running like the 2600s, you got to use the top on the vacuum chambers that tie both vacuum chambers together so that both vacuum chambers open up together. Because if you don't have that top that ties the Venturi vacuum sources together, one will open up, the other will never open up. So you have to have that set up. On a cross ram, I'll throw something at you that you know might make people's heads spin. For the street, general street car, let's say 411 gears or down, 373, 342s, whatever. Yep. I never was ever able to make a double pumper run faster than a good vacuum secondary. Never. We did lots of testing at Mile and Drag Strip and everything else. And the best I could do with a double pumper would have it run dead. And I'm talking basically automatic cars, not sticks.
Sure.
Best I could get it to do was run dead even. Now, when you get into double pumper and you at the line and you launch it, man, that thing come off the line so hard. I mean, you think, man, this must be what fuel injection feels like when it's really good. And the vacuum secondary come off the line, and it wasn't nearly as sharp. But what it was, when you would really watch the car, I had a Firebird we did a lot of testing on, and you'd watch it from the tower, and at about 40 feet out, the vacuum secondary really started coming on. The double pumper, you had this big, the accelerator pumps got you off the line. You really had this feeling of acceleration. Right. And it wasn't that it laid down, but it just didn't accelerate as fast from 40 feet to say 300 feet. It didn't accelerate as much. Now, the double pumper was always good for 1 to 2 mile an hour on top end, always. But when it came to ET, the vacuum secondary was always either just slightly ahead or not quite so much. Now, in a competition car where you're revving it up with a stick or whatever, double pumper's the way to go. But for street performance, the vacuum secondary was fantastic. And on a cross ram like that, the vacuum secondaries over a double pumper would be tremendous.
Maybe I think you may have already commented on this, but read it and tell me what you think, Mark.
Well, yeah, emulsion tubes are important in the metering block, but once they're developed on them in the initial calibration, with all the experience that I have and everything else, I'd never try to mess with those things ever. Without having a wet flow box to mess with them, I would never touch them. That's why I never was impressed with the fact. I mean, screw and air bleeds look great, but big deal. What they do is they lighten up. They cause bubbles in the well. They cause air to get in there, and it causes some air bubbles, and that breaks up. I told you there was this boundary layer of the fuel against the surface of the well that holds it back. When that all bubbles, that helps break that fuel loose and helps get the booster venturi started faster and things like that. I mean, ideally, whether you're talking an intake runner, you're talking the inside of a main well or whatever, the ideal surface would be if it could be dimpled like a golf ball. I mean, that'd be the perfect, golf ball. The dimples make the golf ball go further. And if you could do the inside of an intake runner is like dimpled like a golf ball, or the inside of a main well dimpled like a golf ball, that'd be ideal. But the idea that the bleeds there, your idle air bleed is always much bigger than the high speed bleed. The idle air bleeds are 70, 71, 76,000. The purpose of those things being big is to help when you back off, particularly on the street or in a circle track car. When you back off going into a turn, those bigger bleeds help kill the signal on the idle circuit, so you aren't pulling so much fuel that it'll load the plugs up. Okay? Because you don't want to be loading the plugs up, coming off the turn, getting on it, and it isn't crisp. And so if you get messing with that idle circuit on a circle track car, that's a great way to get a bog off the turn.
How about this?
It was strictly a Holley project. 4160, you actually look at them. The 4160s were developed for the Edsel.
Were they really? With a metering plate in the back.
One of the good things. Huh? Yeah, they have a metering plate in the back instead of a metering.
Instead of a block.
Right, instead of a metering block, yeah. But that concept, the Holleys are what's called a plain tube carburetor. That means there's nothing in the way of the carburetor, of the air. Okay, it's just a, for lack of other words, just a minute here. It's just a plain tube. Okay, It's a plain tube carburetor. Your other big plain tube carburetor is Weber. Okay, Weber's plain tube carburetor. Rochester Quadrajet is an air valve carburetor, has an air valve secondary.
Like a Predator.
And the thermoquad carb, huh?
The Predator carb.
Predator carburetor, that's an air valve carburetor. But there's laws of physics why an air, the quadrajet's an air valve, the thermoquad's an air valve, the Carter AVS is air valve secondary. AFB is aluminum 4-barrel. The AFB is a velocity valve carburetor. It's got a counterweighted plate in there, okay? There's no secondary venturi. There's a counterweighted plate, and the air blows the plate open. The Motorcraft 4100A is a velocity valve. The 4360, that's an air valve like the quadrajet. They don't have a venturi. They got a, if you take a look at the air valve, there's a little contour that as it opens up, it creates like a vacuum, and there's a tube that sucks the fuel out. But let's say you take a quadrajet's rated at 725 CFM at 1.5 inches. But 1.5 inches with quadrajet's different than 1.5 inches with a Holley, because the quadrajet's an air valve carburetor. Holley's a plain tube. What it means is the air density under the carburetor after the air goes through the carburetor is less with a quadrajet than it is with a Holley. It's less with a thermoquad. It's less with an AVS. So you cannot make as much power with one of those other brands because the air density is less. The best way I can explain it, the way I taught at a community college, the way I explained it to my students, let's say you got a big auditorium, and everybody in there is jammed shoulder to shoulder in the auditorium, and each person represents an air molecule, okay? There's only one way out of this auditorium. You've got spring-loaded double doors at the back, okay? Yell fire and see how many people can get out those doors in 30 seconds, okay? So you find out, because everybody goes out, has to keep pushing that door a little bit to get out. That slows everybody up. So the number of particles that get through that door, number of people, is a fixed number. Now, take that door off so there's nothing to impede everybody. Yell fire and see how many people go out. There'll be a lot more, okay? So you got a denser charge in the cylinder. The whole purpose of an air valve carburetor was something like a vacuum secondary, but a vacuum secondary works off of the venturi vacuum, so it's load sensitive. It's pulling the secondaries open based on airflow through the primary. With the air valve carburetor, as the primaries start getting filled up with air, the air pressure starts to push that air valve open to allow air into the manifold. But it's always pushing against a spring, and that's so that the secondaries don't bog out. You know, you can adjust that spring tension on a quadrajet or a thermoquad or whatever, but there's no way an AVS, a thermoquad, a Motorcraft. The only other one, the Autolite 4100 series, that was a vacuum secondary. That was a plain tube carburetor also. If you want to make power, you got to have a plain tube carburetor.
There it is. What do you think about this? This kind of brings up spacers.
I have no idea.
Okay. I can tell you this.
I never messed. I mean, I rebuilt hundreds of quadrajets. I made so much money off quadrajets because quadrajets, as soon as you put a quadrajet in carburetor cleaner, it's ruined. Okay. And the reason it's ruined is if you take a look at the bottom of the main body, there's two steel plugs that the zinc is spun over those plugs. Well, inside under those plugs were O-rings, okay? And they sealed where the secondary jets were. That was all, but it's exposed to fuel. It's in the fuel bowl. Well, as soon as you put the carburetor in carburetor cleaner, the carburetor cleaner takes those O-rings away, and fuel leaks through there into the engine. It just sucks fuel. It runs rich all the time. Okay. So if you want to rebuild a carburetor, a quadrajet right, what you got to do is you put it in carburetor cleaner because you got to get clean, and then you dry it all off, and you mix up some JB Weld. You mix up some JB Weld. You put JB Weld over those steel plugs. Let it sit up at least 12 hours. Go back, put it together, and it'll never leak. It'll be good. And I used to build. There's no BS. I used to rebuild 3 to 4 quadrajets a day. But I never messed with them for racing because I was interested in making horsepower. And you can't make horsepower out of a quadrajet. Needle and seat isn't big enough. You just can't make horsepower out of a quadrajet.
Okay. Here's an interesting one. Hi, Terry. Good to see you.
They split it in half so they basically split them in half so that they can locate them over the runners anymore. Back in the day, I mean, if the manifolds back in those days were made like matter of fact, we drew up two barrel 4500s, we called them 2500s. And we had a design for all of that to make those, but we couldn't get the company to go ahead and fund the tooling.
What about this? I don't know, Dean, what to say on this one. I have no idea.
Well, the 4180C, that was a good carburetor. You know, the 4180C had a lot of good stuff in it. One of the major, and it is about 585. That's right. That's flowing that's wet flow. But they're a good carburetor. Booster Venturis in them it was an annular booster on those things, so it drove really well on the street. It isn't, I wouldn't say it's a great racing carburetor, but if you had a small engine, you could make a pretty good horsepower per cubic inch with one of them. What people didn't understand about Holley's also was Holley's had a thermal expansion problem. Zinc has a cold flow tendency. The Holleys are made out of zinc. And if you take a rod of zinc that's 3 feet long and you hang it in a room, hang it from the ceiling, and let's say 120 degrees, which is quite a bit less than what an underhood temperature would be. But you hang it there and come back in a month and you measure it, that zinc has a cold flow tendency like taffy, it'll stretch. So Holley's had a problem with the, when you tighten down the bolt screw, the main body would warp a little bit where it's sealed against the metering block, okay? You'd see all these guys, they'd mill that thing flat. Well, that was a bunch of BS because it will just continue to warp. What we did, and there were a lot of the street Holleys, that right here where the main problem is this is your accelerator pump passage here. And this passage is under the fuel level. The fuel level's up above that, and this is below the fuel level. But it's the farthest distance from the 4 holes. So as the zinc main body would relax, the seal here at the accelerator pump wouldn't have much pressure on it, okay? And you have vacuum coming right up in that cavity in the main body that activates the power valve, okay? So that's on the manifold vacuum. So at high vacuum, it would just suck the fuel from the gasket. The gasket was real thin here. Suck the fuel past the power valve into the engine, and people would say, and then it'd be a little rich, there'd be a backfire in the exhaust or something. People would say it backfired below the power valve. Holley's didn't, that was the biggest thing. Holley's blew power valves, put a new power valve in, the thing was good to go. We used to get power valves back, all these defective power valves, when we tested them, they were all good. And what it was when you put the new gasket in there, you affected the new seal. And you can see the metering blocks all had raised areas, embossed areas to help keep pressure, localized pressure against the gasket. But what we did for a lot of those carburetors back in the day, we came up with we drilled a relief in here, and in the main body, we had a small transfer tube with 2 O-rings, so that no matter how much it expanded and relaxed that gasket, it would never leak. The 4180s have that in there, and that's a really good setup. Now the reason this was never, and then I developed a field kit to fix this whole problem, and all the parts were put into the rebuilding kits. But the legal team would not allow me to explain how to use the kits. So we ended up putting them in some magazine articles. Matter of fact, they even paid a guy to do an article on me when I had my shop. And in the article, he wanted me to explain about this field fix for the thermal expansion problem. This leak to show that eliminate this fuel leak due to the hot fuel issues. The reason they didn't want to say anything about it, they were selling a bunch of these carburetors to marine outfits, but they were never sold as a marine carburetor. Holley carburetors were used in the boating industry forever, but the boat companies bought them at their own risk, like OMC, whatever. The carburetors were sold as well pump carburetors for well pumps out in the field.
Yeah.
Then the marinizers would take them, put them on the boats. But that fuel leak, when you leak fuel through the carburetor and it builds up in the intake manifold, and then all those fumes are in the bilge of a boat, all of a sudden you got a spark and it goes boom, and you got an explosion. And there were a lot of people lost their lives due to explosions, and possibly, and I don't know if anyone ever directly related to that, but it wouldn't surprise me if there were quite a few. So Holley would never admit they had an issue there. I came up with a field fix back in 1973 to eliminate the problem. All the parts were in all the rebuilding kits. It consisted of, and we can do it sometime if you want, consisted of a tube, a little O-ring, a little split roll pin, and a gasket that had a cutout here. And you just put the roll pin and a washer, a little brass washer. You put the roll pin in the accelerator pump passage right here. It was a split roll pin.
Yeah.
You'd put the roll pin in there, tap it down a little, put the washer over, hammer it down to the thickness of the washer, okay, put the O-ring over it, and then put the gasket that had the cutout. And because that was always below the fuel level, it was always exposed to gasoline, and the O-ring would expand in the presence of gasoline and always provide a seal there. It never would leak. And Holleys don't blow power valves. Good to hear from you, Michael.
We'll just say this one quick, because the bottom line is,
do I have carburetors? Yeah, they were one of the great con jobs of all time. There's no way of making power. When they first came out, they came out as the Kendig carburetor. Remember, Dino Don Nicholson painted Kendig all over his carburetor. We were sponsoring Dino Don, but Kendig gave him a bunch of money. So, but he still ran the Holleys. He ran the Holleys in competition, but he wouldn't let anybody see it. But when we put him on the dyno, we had to motor the dyno up to 3,500 RPM to get the damn carburetor to lean out enough that we could light off the engine. It was ridiculous. So that was, the King of Sweden was involved in this somehow. There was a scam on the funding of the money. Kendig went bankrupt. Predator bought the damn thing. I don't know if it was Predator got the money from the King of Sweden or whatever, but it's an air valve carburetor. There's no way it can make anywhere close to the horsepower that a Holley can.
So you're saying Dino Don, he may have had Kendig on the car, and I've seen those carbs on his engine, but you're saying when he raced in competition, he was running Holleys.
Always. I got stories I could tell you about.
Now, you guys listen to this?
About Jenkins and all these guys. I was in fight with all of those guys.
This is going to be another episode. We're already talking an hour and 52 right now. We got 103 people listening to us, and we could talk. And I told my wife, listen, Andrea, I'm only going to be there for 2 hours, and then we'll call it quits, because I get talking like you. I think you can talk more than me, and we could talk all night about this stuff. It's amazing.
Yeah. Dino Don couldn't make those things fall out of a tree. He always had the Holleys on whenever he was running.
Okay, there you go. Let's go through, because I kind of want to finish up in 2 hours, because we can talk. We can do another one. Now I'm back kind of into this. Here's a quick one, and I'll go through these questions and we'll kind of wrap it up.
The Holley field engineer at General Motors did the calibration on those, along with the guy I was talking about. Well, no, it wasn't Ralph. Ralph didn't work on those. There was another fellow that was one of my mentors at Holley did those. Those tabs were called distribution tabs, and they were designed to make up for distribution inefficiencies at low speed, part throttle, and they were on the boosters. You could see them on all the big box. Matter of fact, the first 780 dual feeds was a 3310 AAS. AAS meant assembly of assemblies for servicemen OEM, and they had the tabs on them. So then Holley decided to make that and they had the Chevy part number. Holley decided to put that carburetor out to the public and as a 3310-1 AAA assembly of assemblies for the aftermarket. It didn't have the Chevy part number on it, but it still had the tabs on the booster ventures. that created issues when you went to the single plane manifolds of torquers and transoms and stuff like that. So we came out with a 3310-2 where we took the tabs off the booster ventures.
Big shout out to you, John Salvatera. $30. Thank you. That'll be going in the DragBoss Garage Fund. You know, guys like Mark that are on here, I always try to hook them up with something, you know, give them some of the money that we collect on this. And that's generous. Thank you, John, for that. I appreciate that. And here's a good one for you. And the reason he's saying this, and for the other people that are on here, is because this is information that you don't hear anywhere else. You've never heard this kind of talk. And we get into talking about other things like cams, his choice on cams, or your opinion on camshafts. You talked about ignition systems. We talked about pro stock racers, guys you've been involved with, like Vic Edelbrock. What did you think of him as a person, to talk to him in an office or to meet him in a social event?
Vic was an impressive guy. I really liked Vic. I liked Vic a lot, and he did a lot for the whole aftermarket.
Yeah, he did. Yeah,
I wasn't too thrilled with McFarland and I butted heads a lot. Jim McFarland and I butted heads a lot. But Vic, I liked him. He was always good at wearing white suits. And my God, he looked like Gabriel the Archangel. You know, I mean, he had blonde hair.
Yeah.
But Vic was nothing but decent to me. He was nothing but decent to me.
Did you ever work with Glidden?
No, I did. I mean, I talked with him on the phone and stuff. An interesting thing there, my wife's best friend, she was maid of honor at our wedding and everything, and she married my roommate. They started a place called Uncle Bill's Pet Shop in Indianapolis. And she says to me one day, she says, do you know a guy by the name of Bob Glidden? And I said, yeah. I said, what about him? She says, he's our biggest single customer. She says, he buys over $70,000 worth of birds a year. She said, he has this huge aviary in his house, you know.
Yeah.
And she didn't know anything about him being a racer and everything. But yeah, I knew he was, what I knew about him, you know, I knew him to say hello to him, but I didn't know him. He was just a super hard worker.
Yep. There's no doubt about that. He was definitely, that's all I saw was wanting to win. You know what I mean? Yeah. How about this?
Boy, that's a name from the past. I can't say I know him because it's too, you know, I've heard the name.
So let's see. We're close. We're 3 minutes away. So we're gonna wrap it up, which is the first time I've ever done anything like this and just kind of kept to my 2-hour minimum. But Mark, I appreciate you coming here and telling us the stories about the Dominators and about racing. And you tell me, or you can get back to me on what you might want to do another talk on. You know,
whatever you want.
That kind of stuff. That'd be awesome to do. You know,
one of the things tuning is what's really. I don't think people understand proper engine temperature. I mean, a lot of for maximum horsepower. They don't understand why the pro stock engines are running the compression they are today. You know, it's because they don't get the engines hot. But I mean, if you're in circle track and you want to make power, you got to run an engine hot. But if you're going to run an engine hot, then you got to run cold spark plugs. And it's a balance about all that stuff. And if you're, you know, running a small block Chevy, a 350-inch motor, the difference between running 200 degrees and 250 degrees, at 250 degrees, you're going to make 40 horsepower more than at 200. It's just plain simple fact.
No, wait a minute. What you're saying is you're going to make more power with the oil at 250 degrees than you are at 200?
Well, I try to keep the oil about 20, but I'm saying if you got the engine coolant temperature, you want the engine coolant temperature around 250. You want those cylinder heads hot.
Right. Okay.
You don't want the heat. You don't want the heat made in the combustion chamber to go into the water jacket. You know, you want it all on a focused piston. I mean, I go to the point where the engines I built for circle track racing, I take great pride in my engines were always the quietest engines out on the track, and I always viewed that the noise coming out of the exhaust pipe was wasted energy. So I wanted all the energy out of that gasoline to go on the top of that piston. I didn't want it going out the exhaust as noise. So my engines were always extremely quiet. And you do that with cam toner.
So there you go, guys. A great interview. I appreciate it. I just don't know what to say. Some of the stuff you've told me, and we haven't even got into the stuff we talked about you know, as far as like some of the BS at the car magazines. You know, you mentioned Jim McFarland. I remember him from, I think it was Popular Hot Rodding. He had a tech article, Tech Corner. You know, didn't he? You write in and ask Jim McFarland.
The tech stuff was in CarCraft. He used to write all his own questions. It was in CarCraft. But he, you know, I started to say something about that. So many of the things that he wrote never happened. I mean, he dry labbed it. He'd say he put a cam in, you got all this out. Here's the dyno curve. Total bullshit. I mean, the Project X, I told you about the Project X 57 Chevy that with Lee Kelly. That was I was present at all that stuff. I went to out to, what was the drag strip? I'm having a senior moment out there near Riverside. Anyhow, when they got done with Project X, Lee Kelly had written that they'd gone at 12.3. Okay, they got out after, and there was like 8 episodes, you know, 8 different things they had done. When they got out there, the best they could do was like a 1283 or 1206. You know, I mean, it was all
instead
BS.
Of 1230.
Instead of 1230. He said, well, it's close enough. There's a hell of a difference between 1280 and 1230. I mean,
there is.
They understood, those people understood that their readership changed by 80% every 2 years in the car magazines.
Okay.
And I was out there at times, I was in Popular Hot Rod Artist Publishing at times where, you know, they'd get an ad that would come in and somebody wanted half a page ad, and they'd go into an article and they'd just take out half of the article to put the ad in. And I mean, they left out a lot of good stuff, you know?
Oh, sure. Okay.
That's just
a lot of embellishment.
Pardon me?
A lot of embellishment.
Oh, embellishment. A lot of there were just a lot of. Well, I won't even get into it. I could tell you stories that.
Well, we're going to hear them. We'll hear all these stories.
We don't want them out there in the public domain. But if I told you some of the stories about some of the people that were in charge of some of this stuff, you would just say, "Oh my God, I can't believe it."
Well, you will. Next time we get on here, we'll have one of a good little topic of talking about the real truth behind high performance industry and racers.
We need to talk about tuning. I think one thing I take a lot of pride in is tuning. Tuning. So many people leave so much horse, pay for a engine off, make a lot of horsepower off a dyno, and they leave so much out of it on the dyno floor just with tuning. What you do for tuning on a dyno is totally different than what you're going to have on a car.
Sure. All right, guys. So listen, we'll bring Mark back. I appreciate all you guys being here. Pedro, Brian Reynoldson, Michael Caruso, Racer D, Anthony Conavino, from Shelby Museum in Las Vegas. I appreciate everybody being here. Greg Dunn. Listen, Andy Wood, I hope you watch this. There's a lot of good information on here from Unity Motorsports Garage. I give a big shout out to all the guys that are working on the No Name Nationals, trying to get the 500 subscribers. These are some shout outs, Mark, if you don't mind.
Sure.
2X Garage. Let's see. Motor City Madness. There's so many that I've been watching over the past few weeks. Hopefully these guys are getting back into it, and the weather's starting to break. You can see back there some motors that I got messing around with next. And I talked to Tony Bischoff at BES Racing Engines in Indiana, where the DragBoss is being built. We're going to go with 55 millimeter cam bearings. I was just going to use regular cam bearings, manganese by Tim Meyer. Tony said there's not a lot of horsepower difference between the regular Babbitt bearing and a 55 millimeter roller. The real difference is when you're working that motor, if you ever turned over a motor with a 55 millimeter cam bearing, roller bearing, he said it's like working on a dream. It turns over so easy. So we're going to go with that on the DragBoss 427. I haven't really talked to you about that, Mark, but that's an engine that I'm building up. It's getting done.
Yeah, I've been on your site watching stuff.
Nice. And you know what? I have a Holley carburetor. I might send you. Have you go through it? You know?
That's okay.
That'd be kind of nice. We'll see what it can do. So I appreciate you guys coming here. I'm going to end the broadcast now. Let me see if there's anybody else we can talk about. Someone talked about the 3-barrel carb. I think that was a 1030.
Yeah, that was all. There was a 950, a 1030.
Yeah.
That was all done for NASCAR, and it really didn't work very well. When the secondaries would start to come open, it would bleed off the airflow through the primaries, and there'd be a bad hesitation. They worked somewhat okay at Daytona, but they weren't a good carburetor. That's why the 4500 actually came out. That's why the 4575 came out. The 3-barrel was a disaster.
Got it. All right, guys, we're going to end the broadcast. I'm going to end it right now. Hang on one second. So you stay tuned because I got a bunch of other guys lining up and ready to rock and roll at DragBoss Garage.